Welcome to the first training session of the Planets project on SSbD. And this is first giving an introduction to SSbD policy background and to the basics of the SSbD framework provided by Carla Caldera from Scienco. Maybe I just quickly introduce a little bit to what we are going to be doing today. So first we will have Carla. Makes fully sense, I guess, since she has been involved in the development of the SSbD framework, that she gives us an overview on the SSbD policy background and on the basics of SSbD framework. Then we are going to be having a more generic look provided by Sabine and Norbert from our university on general aspects of scoping. Scoping has, meanwhile, during this stakeholder consultancy phase, also emerged as quite an important stage. So, for example, at the very early stage, the company needs to somehow consider a couple of parameters before they go into the SSbD development. So, for example, different priorities that are relevant for them. That might be then of quite instrumental when it comes to trade-off considerations of different dimensions in their kind of optimization. We will look into that. And then we are going to be becoming more and more specific to our project. So Josephine is going to be introducing then to us the SSbD workflow, how we are going to be approaching that in our project for the different case studies. And then we are going to be concentrating on the scoping phase, the early phase, again, using the tools that we have and the resources that we have from our SSbD workflow. And I will quickly then introduce a kind of a specific case that we all are going to be working on together in different breakout groups or teams. And it's not gonna be a case that we are working on in the Planets project, but it's gonna be a case that also the stakeholder, or that was also executed during the stakeholder engagement phase. So we have something to work on where we can play a little bit on different considerations. And we do this in breakout groups, and these breakout groups will be facilitated by my colleagues. All right, and with this, I would just like to hand over to Carla to give us the policy background and the basics of SSbD.
Okay, thank you, Martin. So I will explain you a bit the origins of this work and how was the basics that were decided to incorporate in this framework. And so the underpinning policy document that originated the SSbD is the European Green Deal. That, as you might know, there are different strategies. In one of those strategies is the EU Chemical Strategy for Sustainability. And that strategy had put together a plan of key actions that should be taken by the Commission. And one of those actions was to develop the EU safe and sustainable by design criteria for chemicals. So the ambition is to have a set of criteria that will allow to define what is a safe and sustainable by design chemical. And so to that, next slide, please. So to that, we looked at what does it mean to be SSbD, right? So in this chemical strategy, SSbD is defined as a pre-market approach to chemicals that focus on providing a function. So this is the first interesting point. We need to look at the chemical in a specific function, right? So we need to look at the application of that chemical, while avoiding volumes of and chemical properties that may be harmful to the human health and the environment, in particular groups of chemicals likely to be ecotoxic, persistent, bioaccumulative, and mobile. So the focus is in the ambition of a zero pollution, that we would get rid of certain types of chemicals, right? And then we have a second part regarding to the SSbD covering the sustainability. So on top of the toxicity component, let's say, overall sustainability should be minimized including looking at the environmental footprint of chemicals, in particular on climate change, resource use, ecosystem, and biodiversity from a life cycle perspective. And this is an important aspect that connects with the function. So we cannot look at the chemical as just the production at the gate. We need to think, what is this chemical going to be used for, and how is this going to be recycled? So this was the starting point for the development of this framework. Next slide, please. And so what happened in this last time? So at the time we were contacted when the GRC was contacted by the GRTD. So it was a policy on research and innovation. And we proposed the SSbD framework, that is this underpinning report for what was released later in the end of 22, the recommendation. So the recommendation from the Commission that doesn't include all the content of the GRC framework, is a bit more streamlined. And then later on, we also developed case studies to identify the challenges. So all the points that were very often identified as challenged by different companies, we also experienced them. And this was a report published. And recently, they published methodological guidance, giving a bit more information on how to scope the case studies and how to go ahead. And some of these elements were now observed in the planets, as you will see later. It is expected that it's going to be a revised framework because now, along all this period, there have been stakeholders workshops, SSbD boot camps. Everyone that could do case studies could report back and say, so complicated, we need this, we need that, and there's supposed to be a revised framework next year. Next slide, please. And so, what are the underpinning principles of this framework? So it builds on many chemistry, alternative assessment, risk assessment. So it tried to put this together, which is a complicated thing, but it defines a hierarchy that puts safety first to avoid regrettable substitutions. So the idea is that we would also have to define, in this case, cutoff criteria that were very much criticized. So I don't know what's going to happen to them, to the design of chemicals in materials to stimulate sustainable research and innovation that should go beyond what is current regulation. No? So this is an action, R&I action that should be ambitious and wants to go beyond what is current regulation for chemicals. The idea would be to have then an interactively process that will minimize environmental pressures and eventually to have dynamic boundaries and cutoffs. So this was the vision on how this thing could also work. The idea is to ensure optimal use of available data on adverse effects. So every new chemical or material should be compared with existing substances to assess the potential negative impact on human health and the environment. Of course, that data should be fair, so findable, accessible, interoperable, and reusable, so that there is great transparency and that also that the communication is clear and different actors can do the assessments. And the idea of having such a framework is that to have ensure a level playing field. So if everyone does the assessment in the same way, we can then compare and later on go into the market saying this is better than this because we all use the same standard approach, right? Because if that's not the case, it's going to be complicated. Next step, please. Slide. And so the framework has these two components. One component that it reflects how you design a new chemical, right? So you will have a certain idea, and when you are designing this chemical, we can have different principles that we follow. So we can adopt green chemistry principles, circularity principles. There's a number of frameworks that can feed this process, right? And then this innovation should be iteratively followed by an assessment. So at very early stage, we don't have data, okay, but there are some things that we can assess that can give us some direction. And this is where you will see the tier one approach that will be also proposed within the planets, right? But then, as soon as we get more data, our assessment should be more comprehensive. And then we can always go back to these design principles. Say, okay, so what else can I take into account to improve the performance of my chemical? And this was what was thought about on having this framework. Of course, that the industry or the research centers are more involved in the development and innovation part. And we were more looking at what would be the assessment components, what we should look at to make sure the chemicals that came out are safe and sustainable by design. Next slide, please. And so here I'm not going to go into detail, so you can have all this in the reports. And I think also this part is also in the recommendation, that these are what we propose to be as examples of safe and sustainable by design principles. So very known for everyone: material efficiency, minimize the use of hazardous chemicals and materials, design for energy efficiency. And so we give what would be examples of actions that one can take to have these principles reflected in their products, and if needed, also some indicators. So how can I measure if my process is material efficiency enough? So you can use different factors that can help you assess this. So this would be, we have the next slide also with some other principles that can be helped, can be used to guide the development of a new or redesign existing chemical. Then if we go in the next slide. So now we go really on what we are going to assess. Okay, so this is the content of the assessment component, let's say. So, and the first step that we recommend, so although we talk on steps, it's not necessarily that is mandatory, that is a consequential assessment. It's just that for us at the time, and it would make sense that we start with the most critical things first, because if you have a problem with these critical things, there's no worth going and investing and spending time in other stuff. But if people want to start in parallel with other steps, it's also fine. So the first step, it looks at the chemical hazard properties. So it's going to look what are the classification of my chemical. And in this case, we had 3 groups of hazard class, and substance of very high concern, substances of concern, and other hazard classes. And in that case, we propose in the framework that if it was a substance of very high concern, it would never be designated as safe and sustainable by design. Okay, because contrarily to what's been said, oh, it can be safely used, it can be that. In any case, it still exists and it can be released to the environment at some point, because we need to deal with waste and we need to deal with the chemical itself, right? It's not that the chemical, of course, that these type of chemicals, they need to exist because chemistry needs to be reactive and have certain properties. But to designate that as a safe and sustainable by design, it seems a bit counter the concept, right? Then we have the second step that you see already the scheme illustrating there. And there what's happening, we're going to look at what is the exposure of workers to producing that chemical. So we're going to need specific raw materials, we're going to produce it, and we're also going to have to take the end of life. Like, for example, if I need to recycle. So there are different stages of, let's say, production or manufacturing that workers will be exposed. And this is the second step. So here is a risk assessment base, right? To see what's going to happen to workers through producing this chemical. And in here, there's no cutoff criteria. This is just to see the assessment. The third step is still related to safety, and it will look at what is going to be the risk of consumers and the environment being exposed to this chemical. So direct exposure, okay? And then if we look at the next slide, and this is more related to the use part, okay? So then we have the fourth step that is focusing on the environmental sustainability. And so as we said before, as the definition of the SSbD in the policy, we need to look at the entire life cycle, okay? And in this case, in this step, what we're gonna look, at the environmental impacts on the environment and human health via the environment. While in step 3, it was a direct exposure, like you're going to see today in the plasticizer case study, it's someone eating the foods that was in contact with the chemical, right? In this case, the LCA, so the environmental assessment via life cycle assessment, it looks at the exposure via the environment, not only of the chemical we are producing, but all the chemicals that are used in the life cycle. And this is what makes part of the EU recommendation. Okay, this is the core of the EU recommendation, is that the assessment should cover these 4 steps. Additionally, in the GRC framework, we have a fifth step that covers social and economic dimensions. And so we're using also life cycle social assessment and life cycle costing, but also other tools. And so this would be the overview of the assessment as it was proposed. And I think that's my...
Yeah, thank you, Carla.